Alright, I'm here to talk about Tox, which is messaging on the GNU Internet. I came up with that title. It does not work over GNU Net, I have to say that. We just thought it would be a nice title because we do license everything out of the GPL, because we think that is definitely necessary. And so, yeah, let's get started. Quick overview. I'm going to start a bit of what we're doing and why we're doing it, and then get into some of the technical details of Tox. Oops. Yes, the whole point is having a Skype replacement, really, because we think that something like Skype would be amazing to have, because video chatting is pretty awesome, but currently there's no real way to use video chatting securely, because if you use Skype, the NSA knows you're using Skype and they know everything you're saying and everything, and they watch you probably too. So what we thought, we should have a decentralized architecture, so no central servers like that you connect to and then you send everything to that server and the server talks to the other person. That would be a bad idea, so we thought of a decentralized model. And something that's important is that it's configuration free. I'll get into that in a minute. Because, yes, as I said, we want a free as in freedom replacement for Skype. And someone on IRC, I don't know who, whoa, what was that? Someone on IRC said that we don't want to be the next secure messaging system, we want to be the next secure messaging system that people actually use. Because I think that's a real problem that we can't get people to use. We can't even get them to use PGP, which has its problem. We can't get them to use OTR. And so that's usually because they have to set up some things, generate their keys, share their keys on some key service, and it's really annoying to do. So we thought that's something we need to keep in mind if we design this. And yeah, so even, or what is happening? I think I'm leaning on it, sorry. Yeah. So normal people should use it. I guess Jacob just said that parents and grandparents is a little bad idea to say that, so I crossed that out and said normal people instead. Yes, so a quick overview about what we've already done and what we're still doing. We've got text messaging and group chats working. It's completely encrypted and peer-to-peer. We've got audio and video, but we've only have it technically, so none of the existing clients actually implement this. So we still have to do a lot of work there because it's not that easy. And then we have several clients. There's clients for GNU Linux, for OS X and Windows, and they're written in Qt, GTK. There's an Ncurses client, which is currently the official client. There's no real official client, but that's the client that everyone uses. It's called Toxic. And something that's pretty much feature complete is the Python binding for Tox, which is called PyTox. Yeah, and some things that are currently in progress is better network address translation support. The problem is that we're doing a peer-to-peer system, and so we have to build direct connections from everyone. And there is some UDP hole punching, so the whole thing works over UDP, but it's not perfect because sometimes you simply can't get through, and so sometimes when you are behind a net, you simply can't connect. That is a problem we still need to solve, but that's apparently really hard. I'm not a network engineer, but the people who do this say that it's really problematic, and I kind of trust them on that one. Yes, as I said, there's no audio video in actual clients yet, but the people are starting to work on that because they just revamped the API just a bit. And then there's JTalkScore, which is pretty much my project. I started doing that a few months ago. Haven't done much since then. Most of the things in the API are already working, but there's still some things I need to tweak and have a proper API that is easy to use, which is especially necessary for Android clients. I don't think many people will implement Java desktop clients because Java on the desktop is freaking terrible. And so it's mainly so that people can create an Android client. And I don't know if anyone here has ever done JNI, raise your hands. Okay, all of you know that JNI is fucking horrible and it needs to die. Well, you need it, but it's terrible. So,
That interfacing with C from another language. J and I contain, the Java classes contains the information you need to know to call them. Whereas in the C library you only have the name of the function. This is even worse than J.
Yeah, it's bad. Yes, the whole thing. It's kind of terrible. So, a bit about the architecture. Tox is designed to be only a library, so the core is just a library which gives you some functions you can use. It's licensed under the GPL v3, so everyone can make their own client, but they have to license it under the GPL as well. So we thought about LGPL, but so people can kind of close their things down, but we discussed it and we decided it was a bad idea. So it's the GPL, which I think is a very good idea, because freedom is important, especially if you do cryptography and you want something to be secure. So people need to actually see the clients, people need to be able to look at this, and it's kind of impossible to do with other licenses. And one thing, I guess, some licenses authorize you to steal other people's code. I'm not going to use any names, but they start with a B. Yes, I guess bindings to other languages, as I said, PyTox is pretty much done, and then there's JTox core, which is what's done. I don't know if anyone is interested here in making bindings for other languages, but go ahead. The core library is written in C, so you have to make bindings for C for whatever language you like. So, about cryptography. We decided on using Salt or Lipsodium, which is a portable fork, because we thought that coming up with our own cryptography is pretty much always a bad idea. And so we've built on something that's already there and that is pretty known to be working well. So it's public-private key based. And we're using the Lipsodium crypto box functions, which use curve 25519 for the key exchange, which is, according to Wikipedia, what Tor uses as well. And then Salsa, especially X-Salsa 20 for the symmetric encryption, and Poly 1305 for message authentication, so that we have actually messages that are not just encrypted but also authenticated, that no one can actually manipulate them on the way. The network architecture, it's supposed to be a peer-to-peer chat. So you build a connection to the person you want to chat with, and then you talk over that connection. So there's no server involved. And some problems, I guess, UDP was the obvious choice here. Doing peer-to-peer over TCP kind of is weird. And especially the hole punching in TCP is a lot harder than it is in UDP, so we had to do that. The whole thing uses a kind of lossless UDP, which is similar to reliable UDP, which is an RFC standard we do not implement. I don't know exactly why we chose to not use that standard and take our own, but it has some layer that actually acknowledges messages. So because if you do text messaging, you actually need to make sure that the packages actually arrive where they're supposed to be, because your messages will look kind of messy if they arrive either in the wrong order or not at all. So we have to make sure that they actually do arrive, which this does. Then to look up the keys, we also use DHT, and the public keys of each user is the ID in the hash table, and it's mapped to an IP address. So you look up the IP address, not the IP address, you look up the public key, and it hops from DHT to DHT node, just like BitTorrent really. The difference is that since there's no real trackers or magnet links, there's so-called bootstrap nodes, which are just like any other client, but instead of actually talking, they only implement the DHT functionality. So on initial startup, you issue a connect command that connects you to one of the bootstrap servers, and then you start looking for clients. You always know, I think, the 8 closest clients, which is an XOR on the public key, so mathematically closest, and you know some of your local clients. And if you don't know a client, you look up which of the IDs you know is closest to the ID you want to get, and you ask that one. And if that one knows it, it tells you back the IP address. And if it doesn't know, it is the same thing again and asks the next client. This should usually result in 2 to 3 or 4 hops, because the keys, you exhaust the key space really quickly if you have 8 to the power of 8 to the power of 8, and it grows really fast, so it's rather quick. It's not a single hop DHT, which is also possible, but the standards for that are still mainly in development, so we used a classic CAT DHT. Currently, there's...
So if I understand correctly, the first thing you do when you log on is give your IP address to the NSA. Is that right?
Not really, because if the node is controlled by the NSA, yes, you're giving it to the NSA. But it's a peer-to-peer chat system because we thought of ways to do it, but without a central server, video chatting is hard unless you do it peer-to-peer, and if you do it peer-to-peer, you need the IP addresses. I don't think video chatting over Tor is possible because I don't think you can achieve bandwidth that is enough for actually sending video in real time. That is one of the real problems we actually have. Yes?
But the problem is not that you are duplexing the IP address, it's that if someone knows your nickname or whatever handle you're using, they can always retrieve your IP, so they can always be taking the DHT and they know always in which IP you are and they know where you are all the time. You're actually actively like saying, hello, I'm here.
Exactly, that is the problem which I'm actually offering here. There's currently a solution for that. It came up about 2 days after Christmas, so I haven't read it yet, but what I've heard is that we're using ephemeral keys instead of your actual ID. So you can't actually track who you are over different sessions. So in one session you generate a new key and you tell them you're here. And in the next session it's a new key, so it is not tied to your identity anymore. I haven't completely read this thing, so I can't actually explain how exactly it works because it came up pretty late, so I would have done more on that, but I put a link up where it's described, and we're actually looking for people to look over this because we think it's really important that more people actually contribute and look over this because we know of the problems that this has, and we are completely aware that this is really problematic and that we don't really know if this is a perfect solution. It's probably not, but I encourage every one of you who actually has some knowledge in these fields to help us with this because we really need help. Well, there was also a time there was friend request spam because you could look up the public keys. That was solved by adding a no spam ID to your key that is not stored on the DHT, but you can actually look up with the no spam, you can actually find the key, so you can't do that anymore. That was one of the early problems. Yeah, the project is about 6 months old, so it's really new. It's not very far yet, and we have to do a lot of things to actually make this perfect. Yes?
I remember to bit message. Do you know bit message?
I don't actually, sorry.
Bit message.
Yes, I don't.
Bit message is, I think, a similar project, which is sending messages like only to other nodes. Doing this nearly the same as
Not really.
If you send the messages to other nodes, you're really sending them to everyone on the path, and you have to trust everyone. I guess it's encrypted, but you still have to trust everyone on the path with your encrypted messages.
They have so-called groups, and if you send a message to a group, you broadcast to a group, and you can't see from where the message and where the message is going.
I'm actually not sure.
I think we're a bit off topic because BitMessage really couldn't work for telephony. BitMessages works with a blockchain, means that it broadcasts to everybody using BitMessage. All messages go into the blockchain, and everyone picks out the things that are for himself. And so the anonymity is done by throwing it all into one big And that's not a model that can scale in any way for, well, it probably doesn't scale for BitMessage either in the long run.
Yes, because we also do audio and video chat. The text chatting was the first thing we implemented, but we really want to do audio and video because we aim to be a Skype replacement, not just a chat protocol, which makes some of these things actually a lot harder, because as Carlo already noted, that you can't just route it all over the place like that. And especially with the video things, you need a lot of bandwidth. That's obvious. So if you route your video over other nodes, you have a lot of, the traffic increases exponentially, because if two people actually try to communicate via video and you have a lot of nodes, you transmit it all over the place. You have to send all those nodes your actual video data, and they have to send it to the next person. So this definitely reduces the maximum quality, because the maximum quality of that video stream is then limited by the worst connection on the network, which is probably a bad connection, because there's always some bad connections and you might just pick those bad nodes, actually. And that is one of the problems.
Well, that requires a lot of strategy. If you slice the traffic over several circuits and you have a strategy about it, then it probably works. But still, of course, it's a lot of traffic that you're generating, and it depends on what your plans and your intentions are. Maybe you don't want all that perfect video, but you want a lot more privacy. So lo-fi, but with onion routing would be quite interesting. One question that I would like to make is, it's obvious that you're a lot more ahead on the user interface, on the practical sides and that area, and you're new in the field of getting it to work on peer-to-peer and with all that trouble. And now we're having like library kind of implementations that can help you with that. Like Tor has plenty of features like that. GNU.NET has tons of features like that. Doesn't it make sense to merge this stuff and get Tox to be a project on top like Pond?
I think it could work on GNU.NET. The DHT might even work on Tor, because the DHT does not need as much traffic, obviously. So the DHT might work on Tor, and the whole thing might even work on GNU.NET. So that's something I will actually bring to the other developers after this. So if you're listening, well, you will watch this video later. So I guess we can try to talk about this, because especially GNU.NET is something I think that could work, because GNU.NET already offers a DHT, and I think we could work with that. We'll just have to look into it. So if you want to contribute, we are on GitHub, and I put some URLs up there. I can give them to you later. I can put up the slide summary. You can download them, or you can just look it up in your favorite search engine. It will probably show up. The core repository is hosted in the maintainer, the guy who kind of started it all, on his account. And the sub-projects are all hosted in the Tox organization, which has the bindings, which has some of the clients and all of that kind of stuff. If you want to get in touch, we're on Freenode, and the channel's Tox and ToxDev. Yeah, that's about it from me. So if you have any more questions, go ahead.